So we are the Gym Floor Scuffing team, made up of myself, Justin, and my partner, Jesse. We're working with Bona, who is a worldwide leader in hardwood floor care. And Bona would like us to come up with a machine that can test their indoor sports courts to test for scuffing that basketball players might create. So each basketball court is coated in a protective layer of polyurethane. Historically, courts were coated in oil-based polyurethanes, which gave off volatile organic compounds, but they've recently switched over to water-based polyurethanes, which are much clearer and don't give off volatile organic compounds, but they're more prone to scuffing. So Bona would like us to make a machine that can test and mimic the movements that players make on the basketball court and recreate those forces that cause scuffing. So our project is sort of broken into two halves, the mechanical design and then the sensor and graphical user interface design, where everything connects together. So first we had to be able to attach a shoe and take it on and off quickly. And then we had to build a frame that was robust enough to take the forces and to prevent racking. And we also had to make it adjustable for the platform the sample wood to sit on, so you could adjust for differences in the wood type and the shoe type. So first we welded on an axle and ran it through two pillow block bearings, and then ran a down tube, a hollow down tube, and welded that on. And then we welded on a shoe apparatus, and I carved out a fake foot made out of wood and attached that to the shoe apparatus at the bottom. And it's at a slight angle because basketball players stop with their back foot and there's tread on the bottom of the shoe, on the side of the shoe, so they can stop faster. And we think that's the most problematic part for scuffing. Then we added the cross bracing on the bottom and up top. And we also added a ratchet system on top that would catch the foot as it swung past the sample, so it wouldn't come back and contaminate the sample.
So we have the IMU, and it's connected on the top of the shoe, and it will take the important information such as the angle between the Y and Z plane, and so it will tell the user to know how much angle they have pull up the shoe. And also we have a camera to take the before, during, and the after pictures, and those pictures will be processed in OpenCV.
So all our information from the sensors is running into the Pi housed in this case, and then we're running it through Python, and Python is processing all the data for us. And then we have a graphical user interface the Bona chemists will operate and run through, so they can choose their shoe manufacturer. So whatever shoe is the problematic shoe, they can choose that. They can choose the amount of weight that's added to the bottom of the pendulum, and then after the pendulum swings, OpenCV, which is a Python program, will process the before and after picture and tell the difference, and that is the amount of scuffing that's produced. And then all of that information gets stored into a folder on the home page of the Pi, so the Bona chemists can reference that later.